In this lesson, you will learn to determine the geometric mean between two numbers, as well as how to state and apply the relationships that exist when the altitude is drawn to the hypotenuse of a right triangle. So we need to begin by dealing with the parts of a proportion. So a proportion, as we've learned in a previous lesson, are two ratios that are equal. So for example, if we have a to x, that equals y to b. We have two ratios that are equal. And we could write this as a fraction as well, where it's a over x equals y over b. Now the a and the b are called the extremes, and then the x and the y are called the means. So whatever numbers are in those positions, so whatever numbers are in the top left and bottom right, we call those numbers in a proportion the extremes, and the bottom left and top right we call the means. Now looking at the means, there's a specific type of mean that we have called a geometric mean. And for example, it might say to find the geometric mean of two numbers, such as 4 and 9. So what the geometric mean means is that we are plugging in a 4 and 9 into the extremes, and then putting an x in for the means. So we have 4 over x equals x over 9. So make sure that you can convert from the geometric mean as stated in English into this math notation written as a proportion. So one more quick example. If I said to find the geometric mean of 3 and 12, what I do is I put a 3 on the top and then a 12 down here in the bottom, then put an x at the different mean locations. And then from here, looking back at the first example, I then solve this for x. So I can solve by cross multiplying. I have x times x, which would give me x squared, equals 4 times 9, which would be 36. So x squared equals 36, and then whatever x is equal to, that is going to be what the geometric mean is. So here, x squared equals 36. I can take the square root of both sides to get rid of the squared. So when I take the square root of both sides, what I have on the left side is the square and the square root will cancel each other. I'm left with an x on the left side, and then a square root of 36 on the right side. So x equals the square root of 36, so x would therefore equal 6. So in a moment, we're going to use the geometric mean to solve different things. But first we need to now introduce you to a theorem. This theorem says that if you have a right triangle, so this big right triangle, ABC, and then you have this altitude drawn from the vertex, from the right angle of the one triangle, down to the other triangle. If that is the case, then the different triangles that are formed will all be similar. So notice we have three triangles. We have a big triangle, and then we have a triangle on the left and a triangle on the right. Each three of these triangles are similar. So the theorem says that triangle BAC, the big triangle, is similar to the triangle on the left side, which, if you can't visualize that, the triangle on the left side would be BDA. And then that's similar also to the triangle on the right side, triangle ADC. Remember, similar means that we have shapes that are looking the same but may have different size. And with similar shapes, we have all the angles will be congruent and the sides are going to be proportional. And take note as well of the different vertices that are paired up. So looking at the triangle on the left, triangle BDA. So we have B and then D and then A. Notice how they're paired up with the triangle on the right. We have the B pairs up with the A up here. And then the D pairs up with the D. So these two pair up. And then the C pairs up with the A. So the top vertex for the left triangle. So C corresponds with the A. So if you can visualize taking the triangle on the right here and kind of rotating it so that the A would be down here on the bottom left, and then D would be down here at the bottom right, and then C would move up here up to the top. And that is how the two triangles correspond. Now, yes, that is a theorem, but we're not going to take the time to prove that here in this video. But we're going to use this theorem to draw a conclusion, and we have two corollaries, which are logical statements that follow directly from a theorem or a postulate. So corollary 1 says that when you have this picture, then the length of the altitude is the geometric mean between the segments of the hypotenuse. So the altitude is AD, and it says that AD is the geometric mean between the segments of the hypotenuse. So we have segment BD, and then over here segment DC. So using math notation, we would say that AD is a geometric mean, so we put AD down here as the means. So AD in the bottom left and the top right. So this length of the altitude is the geometric mean. And then the other two numbers we put would be the length of BD, so right here, and then DC is the length of this segment right here. So that's what the corollary says, but then how do you actually use this? Well, here's a picture where we are trying to find the value for x. X is the altitude. It is the length or the distance from A to D, and this is going to be a right angle right there. So then what we can do is we know that x is the geometric mean of 3 and 12. So when I set up my ratio, my proportion, x is the geometric mean, so x would go down on the bottom left and on the top right, because those are the means of the proportion. And the 3 and 12 would go here and here. So my proportion would be 3 over x equals x over 12. So then from here I can cross multiply to solve for x. So x times x would give me x squared. 3 times 12 would give me 36. So x squared equals 36. I can take the square root of both sides. So now I have x equals the square root of 36, which would equal 6. So I can use the geometric mean to solve for the unknown altitude. And then using the same picture, but now we know the altitude to be 6, we're trying to find the other length of this segment. We can use the same fact that this altitude, the 6 in this case, is the geometric mean of 3 and x. So what I can do is I can say that we have this proportion, and because 6 is the geometric mean, 6 would be in the bottom left and the top right, because those are the means of the proportion. And then the 3 and the x would go here and here. So now I can solve that for x. So when I solve that, I have 3 over 6 equals 6 over x. I can cross multiply 3 times x and then 6 times 6. So I now have 3x equals 36. I can then solve for x by dividing both sides by 3. Now I have x equals 36 over 3, which would equal 12. Here's a second corollary based off the theorem where, given the same picture, we know that this relationship will be true. Now let me walk you through what this means with this notation, the CB over AB equals AB over BD. So what that means is if you were to take this picture, and let's say you were to just look at the triangle on the left side and then the big triangle. So here we have redrawn the big triangle, and then we have the triangle on the left. Another way we can think of this proportion is that we can take the big triangle's hypotenuse, divide that by the small triangle's hypotenuse. That will equal the big triangle's leg divided by the small triangle's leg. So looking at the big triangle, the hypotenuse by definition is across from the right angle. So looking across from this right angle, this down here would be the hypotenuse of the big triangle. So if we take that length, the big hypotenuse, divide that by the hypotenuse of the small triangle. So the small triangle, here is a right triangle, the hypotenuse would be across from that. So length AB would be the length of the small hypotenuse. And then looking at the big triangle, the leg would be on the other side. So AB would be the leg of the big triangle, and then the leg of the small triangle would be BD right here. So this is the relationship. We take the big hypotenuse over small hypotenuse equals a big leg over small leg. So let's look at two examples on how to use this. Here's example 1. So using this picture, we're trying to find x. And we know the relationship will be big hypotenuse over small hypotenuse equals the big leg over the small leg. So here it might be helpful to draw or redraw the big triangle and then maybe highlight the triangle we're looking at. Since we're trying to find x, which is on this left triangle over here, the triangle on the left side, we're going to redraw this so that we have the big triangle and then the triangle on the left. So the big triangle, if we know this length is 3 and then the other length is 12, if we add those together, the entire length would be 15. Okay, so I'm looking at this big triangle with a length of 15 and then the small triangle on the left side. So if I take the big hypotenuse, which would be the 15, it's across from that right angle, and then the x would be the leg of the big triangle, and then the small triangle, the hypotenuse would be over here, so we have the small hypotenuse, and then the 3 would be the small leg. So if I just plug these numbers in, 15 over x equals, and then it's going to be x over 3. So take a minute and make sure you understand where those numbers came from. 15 was a big hypotenuse, that goes on the top, and then the small hypotenuse over here was x. So 15 over x, big leg was x as well, and then the small leg was the 3. So we have 15 over x equals x over 3, which I can then solve for x by multiplying across. We have x times x gives me x squared. 3 times 15 gives me 45. I can then take the square root of both sides. So now I have x on the left side. On the right side, we have the square root of 45. And then if you wanted, you can either plug this into your calculator to get 6.71, or if you keep the radical sign in there, you can break it apart as a product of 3 times 3 times 5. So I can then pull out a group of 3's. So now I have 3 times the square root of 5. Either way is fine, just make sure you follow directions. If one method is asked over the other method, make sure that you do the method that is being asked. And let's look at one more example, where what if we're trying to find the right side over here? Well, if you're trying to find the right side, the same proportion will still be true. Big hypotenuse over small hypotenuse equals a big leg over the small leg. So if I want, I can redraw this, where now I have the big triangle down here at the bottom. 3 plus 12 would give me 15 for the total length down here. And then I'm only concerned with the triangle on the right side because I'm trying to find the length of this right side over here. So I can ignore the left triangle. So what I'm doing is I'm trying to solve this for x. And I'm not sure why this disappeared, but there should be an x still there. And then what I want to do is plug things in. And to do that, I need to determine what is the big hypotenuse, big leg, small leg. So looking here at the big triangle, the hypotenuse is across from the right angle. So this would be the big hypotenuse. And then the x over here would be the leg. So this would be the big leg. And then the small triangle up here in the top, the hypotenuse is across from the right angle. So the x would be the small hypotenuse. And then the 12 would be the small leg. And what I can do is plug everything in. So the big hypotenuse, we put a 15. Small hypotenuse was an x. So we have 15 over x. And then big leg was x. And then small leg was 12. So we have x over 12. And then from here I can cross multiply. X times x gives me x squared. And then 15 times 12 would give me 180. So then to solve for x, I can take the square root of both sides. Now I'm left with an x on the left side and the square root of 180 on the right side. And the square root of 180, if you use your calculator, you'd get 13.42. And if you were to write with the radical and just simplify, 180 was 15 times 12. Right, so I can break this down. So 15 and 12. 15, I get 3 times 5. 12, I'd get 3 times 2 times 2. So if I simplify this, I have 3 times 3 times 2 times 2 times 5. I can pull out a group of 3's. So I got a 3 on the outside. And then pull out a group of 2's. So I have a 2 on the outside. Now I have 2 times 3, which is 6, and then a square root of 5 left over. So either is fine, just make sure that you follow directions. And that concludes our lesson for today. We will see you next time.